Okay, we are live. So for some reason, when I was posting the quiz, the quiz had some issues. Apparently it was missing images, so I had to delete that quiz and then upload a new quiz. And when I uploaded the new quiz, it didn't go out to all my classes, even though I clicked on all the classes. So I'm having to make sure every class has access to the quiz now. For some reason, third period still doesn't have the quiz uploaded. It's just what I need. Okay, everybody should have access to the quiz now. All right, we got about 30 people in here right now. That's not too bad. Not too bad. So while you guys are logging in, let me go ahead and give you the code, the Nearpod code. So I'm gonna make an announcement. Nearpod code is VDTRJ. VDTRJ. Probably should have said Nearpod code. There we go. Is count for our attendance. Yes, Amani. Attendance is mandatory. My 35 kids. So I'll let people log in Nearpod right now. I've got 11 kiddos in here, or 12 actually. Alrighty. We're doing good. I'll just give it a couple more minutes. We will start the actual Nearpod at 12:10. That way more people can come in, log in Nearpod, and get on board before we get started. Zamari, show dog. The dog is around. I'll bring the dog out later. She'll make an appearance, don't worry. Natalie, how do you know who is here or not? Well, one, if you log into the Nearpod, I can see everybody in the Nearpod. And two, I can look at the logs before or after the live session and see who logged in and how long you were logged in. So if you log in for 2 seconds and then log out, I'll know. My cat's sleeping on the bed. Chill out. Oh, awesome, Diego. You're recovering. Can we keep this physics related? Yes, I've been playing Animal Crossing. Probably a little too much.
What is Animal Crossing?
It's a game on the Switch right now.
The Nintendo Switch?
Yeah.
Mr. Hunt got one of those.
Oh, really?
That's what he told us yesterday.
I should bother him for his code.
You should.
All right. So got quite a few kiddos in here. 28. Just a couple more minutes and then we'll get started. Still want to give people a chance to log in before we get started. Do I time travel in Animal Crossing? No, I'm not a cheater, okay? I'm not giving out my friend code, Cal, sorry. Will you chill out? You can see our little floppy ears here. Oh my God, Jack. No, I'm not adding kids. How's it going, Edwin? There are no such thing as ugly residents, Daniel. Yes, the frog chair is gone for good. How do I feel about not seeing you for the rest of the year? Meh. Why do I favor my cat over my dog? I don't. Much. Clark, I'm glad that you can join the sessions now. Janaya, if you don't have a grade in for the guided reading, then you need to complete it because I don't have any paper copies right now. But if you already have a grade on Infinite Campus, then don't worry about it. Where is your dog mug? No dog mug. I pet my cat like a dog? I don't know what that means. Anyways, we're gonna get started. We got stuff to do, okay? So let's start going through this Nearpod. It looks like we got about 36 people in here. Miss Allie, do you think I should cast the Nearpod, or do you think I should just run through it?
So when I did my other class last week, granted it wasn't a live session, but we just kind of, I did not cast the Nearpod because my expectation was that they were all on it.
Yeah, and that's kind of what I was thinking too. Is the Phet Lab mandatory? Yes. And if it says to draw a few things, just screenshot things and upload it into the document. You don't have to actually try to draw in the assignment.
Stop emailing my mom. That's what one person said.
Well, I don't know who you are, so I can't. Sorry. I can see your faces if you ask to do a live session or a live meeting, which is available for 20 Sparta bucks. So, yeah. Okay, so let's go ahead and get started. I got 39 people in here, minus me and Miss Allie, so let's get going. So today we are talking about electrical circuits. And Miss Allie, if there are any questions like that seem important, just let me know and I'll answer them. So electrical circuits is the name of the game today. So we're going to talk about what circuits require and how to measure voltage and current and resistance depending on where you are in the circuit or what type of circuit that you have. So just a little refresh, an electric current is the flow of electrons through a circuit, right? And we know that electrons flow from the negative terminal to the positive terminal. So from that negative side all the way through the wire back to the positive. Now when we talk about current, we actually say it goes from positive to negative because this is the original way that people talked about current. So I know that's a little confusing, but current flows from positive to negative. Electrons actually flow from negative to positive. Now this won't be too important because I don't think we'll get into that much detail due to being a teleschool. But if any of you guys run it, like go into electricity, this is a common thing. Any of my electrical engineers out there. So a simple circuit kind of looks like this. So we have a cell or a battery that supplies the voltage, and then that's connected to a couple of different components in the circuit. So here we got a light bulb and a switch. So notice it is all connected directly, right? Now, the key here is that there are no broken connections. In fact, this switch can break the circuit. When it's open, that means that the circuit is broken and there aren't electrons flowing through. But once it's closed, it completes the circuit, and then we have a full, or the current can actually flow when the circuit is closed. And of course, this whole PowerPoint is will be available on Teams later. I will post this whole thing, so don't worry if you get lost behind. So, like I said earlier, when the circuit is closed, then you have a continuous path that the electricity can actually flow. And this circuit right here is actually a series circuit. So the battery, the light bulb, and the switch are all in series with one another. That means that it is just one continuous path for it to take. So here is an open-ended question for you guys to answer. what is the current of a circuit if the voltage is 10 volts and the resistance is 5 ohms? Can you guys calculate the current of the circuit? So go ahead and give that a shot and submit it to me, and I will check your answers. So if you can do this, then you'll probably do pretty well on the quiz that I posted as well. Alrighty, looks like we got a couple answers right now. Alrighty, got about 40% that have answered. And whoa. So if you guys remember, Ohm's law tells us that resistance equals voltage divided by current, right? So voltage, if you're looking for current in that case, you would have to rearrange your formula from resistance equals voltage divided by current, and you would instead have current equals voltage divided by resistance. So here you actually have V divided by R. So when you divide 10 by 5, of course, you get 2, which is what most of you guys answered. Most of you. Got a couple 50s in there, not quite right. It should be 2 amps. You should have gotten about 2 amps for your current. So let's keep going. It's all right if you got that one wrong, just make sure that you understand the 3 different forms that Ohm's law can come in, okay? That was, of course, from last week. So if you're looking at a basic circuit diagram, so this image over on the left is kind of what it would really look like, but the image on the right is how we would draw it, because it's, you know, it's complicated to try and draw light bulbs and switches and batteries. And so we simplify everything so we can quickly draw them and recognize immediately what each component is. So typically cells will look like a long line and a short line, and then batteries will usually look like that cell duplicated twice. It'll look like that just 2 times. A lamp is usually a circle with an X in it. Switch will have these 2 dots and a line that's either open or closed. And then the wire is usually just a straight line. So these are the most common that we'll use. And of course, lamps act as resistors. So they resist current, or they resist the flow of electrons, and that's actually what causes them to light up and glow. So here's some more that you might run across in different circuit diagrams. You'll see, occasionally you'll see a buzzer. The battery, like I said, is the cell just twice. A resistor will just usually look like a block or will look like squiggly lines. And then a variable resistor, which means that you can change the resistance of that resistor, will have a line going straight through it, or an arrow going straight through it. Of course, an ammeter and a voltmeter have an A or a V representing them. And we'll talk about how to use those more in just a second. So there are 2 main types of circuits that you'll run into, and I think we talked about this a little bit last week, but now we're going to go into more detail. So a series circuit is a continuous circuit that is just one full series. So basically everything is directly connected to one another. There is no other path to take but through each component in the circuit. A parallel circuit, on the other hand, has different paths that electricity can take within the circuit. So the battery, of course, is the positive and negative part. And if you follow the red wire, so you can either go from the battery through the red wire and just completely skip that first light bulb and go through the second light bulb instead. Or you can go from the battery through the first wire and then skip, or through the first light bulb and then skip the second light bulb and go straight to the battery. This is called a parallel circuit, where you can take a different path depending on which way you go in the circuit. So you can either go through light bulb 1 or light bulb 2 in the parallel circuit. You don't have to go through both.
Mr. Smith, someone had asked, what's the difference between a battery and a cell?
That's a really good question. Honestly, you don't really use cells very often. I don't think I've ever really bothered to look it up. So a cell is basically just a less complex battery. So a cell holds a charge, whereas a battery can be made up of multiple cells. Like, it has multiple places that hold charge within the battery. That's kind of the extent of it. You guys don't really have to know that. So just think of it like a battery. Does that help? Whoever posted that? I mean, a battery is just a complex cell. They both hold charge. Okay, let's keep going. So, like I said, a series circuit is connected from end to end, one after the other. It's all completely connected. So the important part about this is that if one light bulb blows and it breaks the circuit, the other light bulb will go out as well. So if this first light bulb goes out, light bulb 2 will go out as well. This is pretty similar to, like, if you guys ever put up like Christmas lights or a series of lights ever. When one goes out, they all go out, or at least a bunch of them go out. This is because they're in series with one another. So that's just how a series circuit works. It's basically like opening the circuit and cutting it where that light bulb would be. Of course, it doesn't flow anymore if the circuit is broken. Parallel circuits, on the other hand, have that branch. So if light bulb 1 goes out, or that top light bulb goes out, the second light bulb will still glow because it's still directly connected to the battery. So the two light bulbs have different branches or different paths that it can take. So this can be really useful when you're putting a bunch of things together, and one might break, and so the other one is there as backup, basically. Or the other one will still function even if one goes out.
Mr. Smith, so someone asked, is anything that uses energy in the circuit, wait, hold on, I'm sorry. Anything that uses energy in the circuit is a resistor? Question mark.
Uses energy in a circuit as a resistor. Yeah, pretty much. Everything has resistance. Everything in the circuit has a certain amount of resistance. Light bulbs are basically just glowing resistors. The main purpose of a resistor, though, a actual made resistor, is to slow down or to push back on the circuit. or the current. So if the current is flowing too high, then you'll actually cause things to overheat, and you can damage the components of the circuit. So we'll put in a resistor specifically to slow down the current. But everything acts as resistance. So you'll actually slow down the current when you put a light bulb into the circuit. And if you have too many light bulbs in series, then it'll actually slow it down to where none of them will light up. Fran, are Christmas lights an example of parallel circuits? Actually, it's kind of an example of both. So when one light bulb goes out in a thing of Christmas lights, or holiday lights, if you will, typically a bunch of them will go out, but not all of them. It depends on the type of lights that you buy. When one goes out and a bunch go out, that means all of those were in series with one another because they were all directly connected. But when one goes out and some are still glowing, then that means those lights are actually in parallel because they're still functioning and the light bulb that went out is actually out still. Does that make sense? So when one light bulb goes out and more go out, then that's in series. But if one light bulb goes out and the others still work, that's parallel because you have multiple branches in order to complete the circuit. So Christmas lights, or holiday lights, if you will, can be kind of both. So let's keep going. We'll get an opportunity to look at series and parallel circuits in a second, or explore them further. So let's talk about some math. So when it comes to current in a series circuit, so this is where everything is directly connected to one another, the current in a series circuit is always the same no matter where you are in the circuit. So no matter where you measure the current, it's always the same for series circuits. So you can see that equation down here. The total current equals current 1, and it equals current 2, and it equals current 3. This is basically saying wherever you measure the current, it's the same as the total current in the circuit. Now, voltage, on the other hand, the voltage across each component is different than the total voltage. In fact, you have to add up all the voltages across each part in order to find the total voltage. So basically, this means that in a series circuit, each component has a different amount of voltage that it pulls or it drops. This will make sense more when we look at a diagram. So if you want to write that down, voltage total equals the voltage across each component, or voltage 1 plus voltage 2 plus voltage 3. Basically, however many parts you have in, the voltage across each one added together will be the total. Once again, this whole PowerPoint will be posted online later, and you'll be able to follow it, as well as practicing this stuff in the assignment posted in Teams as well. So the resistance acts the same way as voltage does in a series circuit. So you can see the resistance, the total resistance in a circuit is each component's resistance added up together. So if you have 2 light bulbs and a resistor, to find the total resistance in that circuit, you have to add up the resistance of each light bulb and then add the resistance of that resistor to find the total. Now, this is only for a series circuit. Series circuits add up directly like this. You'll see in parallel, it gets a little bit more complex. So here's another diagram of a parallel circuit. This is just repeating exactly what I've said before. Resistors are connected in separate branches. There are different paths for the current to take. This is important because when you're calculating voltage, voltage is actually the same across each part. So the total voltage in the circuit is the same across each branch in a parallel circuit. So that means if you have a 5-volt battery, then each branch will have 5 volts running through it. So the total voltage equals voltage 1, which equals voltage 2, and that's the voltage on each branch. So that's very different than we saw in a series circuit. Parallel circuits act very differently. So don't worry about trying to do this math. We're not gonna do parallel circuit resistance just because it's a little bit more complex. Now, when you go into college and stuff, you will definitely be doing this. But for this class, because we're doing Teleschool right now, we're going to try not to overcomplicate things. So you can see the total resistance in a parallel circuit is actually 1 over the total resistance equals 1 over the resistance of one component plus 1 over the resistance of another component plus 1 over the resistance of another component. So that's a little bit more complicated than it was in a series where you could just add up all the resistance directly. Here you have everything over a fraction, which really complicates things. So trying to find the resistance in parallel circuits is a little bit more complex. Now, if you're trying to measure current, of course you use an anomer, which is one of these little bad boys. And we'll represent that with a circle with an A in it. Now, when you're using an anomer, you have to directly connect it into the circuit. It has to be part of the circuit this time. So if you're measuring the current in a series or a parallel circuit, it has to be directly connected into the circuit. It's basically just another part, or it's in series. So you can think of it kind of like if your anomer broke, then the circuit would be incomplete, just like if a light bulb broke in that series circuit. Now, when you're measuring the total current, you have to put it outside of one of the branches. So each branch connects and then goes through the anomer. That is vital if you're trying to measure current through the circuit for a parallel circuit. Okay. So here it is again. So for a series circuit, if you're measuring current, every part of the circuit is the same for current. So the current, if it's 2 amps over, on the right side, then it's 2 amps in between the light bulb, and it's 2 amps over on the left side as well. It's the same current throughout the entire circuit for series. Whereas parallel, it splits when you get to that branch. So if you have 2 amps total of current going through the circuit, you have 1 amp of current going through one light bulb and 1 amp of current going through the second light bulb. So it kind of splits. And of course, they won't be directly like half, because it depends on the resistance of those light bulbs. But for now, we're just going to keep it simple and say, well, if these light bulbs are the same, then your current is just cut in half. Okay? So it's shared between components.
Mr. Smith?
Yep.
I just had a thought that came to me.
Go for it.
So because people might log on late, it might actually be a good idea to display that in your pod. You don't like my idea?
No, I don't like it. Yeah, I'll
I mean, just like to stream it, whatever.
Yeah, definitely.
Okay, cool. All right, sorry about that.
No, you're
Everything's great, no questions on this end. But if you guys do have questions, please enter them in the Q&A.
Can you see it now? Is it, no, it's not. Okay, there we go. Sorry, that's a great point, especially if somebody wants to go back and look at it. Real hard to do when you don't have the Nearpod. Okay, so let's get back to it. So like I said before, the current is the same throughout a series circuit, whereas it is shared within a parallel circuit. So let's keep going. So here's a question for you. If you have these two diagrams, what would the current be in the left one, and what would the current be for each component of the right one? So let's give that a shot. Go ahead and draw in what you think. Yeah, did a little fill in the blank here.
While they're working on that, Mr. Smith, Ethan is wondering, in a circuit with a resistor, how does the light bulb get brighter? Does the resistor take power away from the light bulb that allows the bulb to get brighter?
Does the resistance take power away from the bulb that allows the bulb to get brighter? Okay, so basically, if you want to, how does the light bulb get brighter? Oh, you have to change something about the circuit if you want to brighten the light bulb. So if you have a light bulb in a circuit, in order to increase the brightness, you can increase the voltage going across the light bulb. Now, it also depends on if you have a series circuit or a parallel circuit. Like a parallel circuit, all the light bulbs will actually have the same brightness, whereas a series circuit, each light bulb will actually be dimmer because they're in series. I don't know if that helps you. You're gonna have to be a little bit more specific with your question, Ethan. The resistor, I mean, definitely resists, and so the higher the resistance, the dimmer the bulb. So the lower the resistance, the brighter the bulb. So if you either increase the voltage or you just get a less resistant light bulb. I don't know. Does that help? Let me know. Let me know in the comments below. All right, let's see what people are posting here. Looking good. Not too bad, not too bad. Watching people try to draw on this is hilarious, by the way. So Sierra, remember that in a series circuit, the current is always the same no matter where you are. Derek, the black parts in the like those black circles are what you're trying to tell me what the resistance or the current is there. I'm sorry. Adrian, good job. There you go. There's your shout out. Good. Most of them are looking really good. But yeah, your parallel circuit is perfect. So it looks like you got it. Your series circuit looks good as well. Ethan, that's just a big smiley face. That's not current at all. Imani, you just wrote A's. Here, let's pull one up so we can see the answers. Let's go with Austin. There you go. So this is what it should look like, where you have the current in the series circuit, the one on the left, is all the same. So no matter where you are in that circuit, you have the same resistance. Or, I'm sorry, the same current. Whereas in the parallel circuit, each part is actually being shared, or the current is being shared for each part. So each branch has about 1 amp going through it. Now this is under the assumption that each light bulb has the same resistance. But you notice that the top left current in that parallel circuit is 3 amps. That's because after all of them are back connected to one another, going back to the battery, it's the same total current in the circuit. So that's really good. All right, let's keep going, guys. All right, so when you're measuring voltage, on the other hand, you use a voltmeter. And of course, you represent the units as volts. Nothing fancy about that. So when you're using a voltmeter, you actually put it in parallel with your circuit. You don't have to put it directly into the circuit. You just connect it on the outside or in parallel. And of course, when you're measuring voltage, you're actually measuring the potential difference. So the potential electrical energy difference from one side of the battery to the other is what you're actually measuring here. Chill out, pup. Chill out. So let's keep going. So basically, a voltmeter has to be connected in parallel, just like this, and you're actually measuring it across a light bulb. So before we were putting it into the circuit, whereas here we're putting it on both sides of a light bulb. So you wouldn't connect it directly here in the center of the 2 light bulbs in series. You actually put it on one side or on both sides of one light bulb to measure the voltage across that light bulb. That's how much energy that light bulb is drawing. And of course, you treat it the same way in a parallel circuit. You're basically just adding a new branch on the circuit. And this is just connecting a voltmeter across every single light bulb in the circuit. So my question to you guys, what would the voltage read, or how does the voltage change differently for a series circuit than parallel? Think about that for a moment. You don't have to actually answer it yet. Actually, I think I have a question right. Oh, here's the answer. The voltage is shared in between the components in a series circuit. So if we have 3 volts total from the battery, each part or each light bulb is drawing about 1.5 volts. Once again, this is under the assumption that each light bulb is exactly the same. But both of the light bulbs, the voltages added up together should be the total voltage in the end. And of course, that's different for parallel circuits. Each light bulb in a parallel circuit is drawing the same amount from the battery. So each light bulb draws 3 volts, just like the battery is giving off 3 volts of energy. So we're going to do another couple questions. Put your knowledge to the test. There you go. So here I want you to tell me the current going through in between the light bulbs and over here on the right. And then I want you to tell me the voltage going through each light bulb here. Okay, go ahead. just give you guys a couple more minutes, or a couple minutes to take care of that. So think about the total voltage supplied by the battery, and think about how does voltage change in a series circuit. Okay, so how does the voltage change in a series circuit versus a parallel circuit? So those V's are asking for the voltage across each light bulb, whereas the A is asking for the current. Sally, I can see that you're not drawing anything right now, so I'd appreciate it if you actually got to work.
I apologize, Mr. Smith. I'm so focused on the Q&A.
Good job, Jenny. Good job, Camden. Austin. Amani, you got the voltage. Kayla, good job. Adrian, think about the total voltage supplied. Bella, think about the total voltage that is coming from the battery. Megan, how does the voltage change in a series circuit across each light bulb? Brandon, those are just check marks. I don't know. I don't know what that was trying to tell me. China, those are circles. You're supposed to write in numbers. Cal, you're not stupid. You just need to, put in the numbers. Edwin, think about the total voltage. And remember, in a series circuit, the voltage across each light bulb should add up to the total voltage supplied. Can you look at my question on Teams? I don't know what your question was. Is it in the Q&A? Trying to refer to the quiz question that asked the bulb will get brighter. Okay, hang on. Okay, so that quiz question, number 4, I believe. If you think about the Hang on, I'm still waiting for the image to load so I can be a little bit more specific. Basically, think about what would change the voltage going across the light bulb. So a light bulb is only as bright as the voltage going across it. So the higher the voltage going across it, the brighter the light bulb. What could change that voltage? Think about Ohm's law. Hopefully that helps. All right, let's take a look at these images. I see some 2s. Here, let's pull up. Who's got a good drawing here? Who's got a good drawing? Let's go with Kayla's. It's not bad. It's not bad. So the current across each part is 4 amps, right? So a series circuit, the current is the same across every part, whereas the voltage is shared because it's in series. So if we have a total of 6 volts, each light bulb is pulling about 3 volts. So if you wanted to increase the voltage going across one of the light bulbs, you could remove one of the light bulbs. That would increase the voltage in the other light bulb. Only for a series circuit though. So let's go on to the next question. So here's a parallel circuit instead. Let's find the voltage and the current for a parallel circuit. So give this one a shot real quick. And I'm gonna grab another cup of coffee. Okay, sorry, I'm back. Let's see what we got here. Okay, so guys, remember, how does voltage react when it's in a parallel circuit? How does the voltage change if it changes in a parallel circuit? And then how does current change in a parallel circuit? So remember, it's very different than a series circuit. In fact, you can almost think of it as opposite. Derek, your current was right, but your voltage is wrong. Sierra, your voltage is right, your current is wrong.
Mr. Smith, Ethan is asking, what is potential difference?
Potential difference is basically the definition of voltage. A battery has a positive and a negative side. Now, the difference in that charge is actually the potential energy on one side versus the potential energy on the other side of the battery. That is the potential difference. Okay, so we represent energy within a battery as voltage rather than in joules, but you can actually represent energy in a battery as joules, just like we were showing potential energy last semester in joules. Electrical potential energy is another type of energy, just like gravitational potential energy or elastic potential energy. So that potential energy is the difference in the charge. And the higher the difference, the higher that electricity will flow, or the more the electricity will flow.
Oop, Diego Lopez has chimed in. So on the parallel series, the voltage is the only thing that changes, or the current changes too?
Kayla nailed it. So here, take a look at this one. Why is it not showing? There we go. So if you look at this one, the voltage is the same for each light bulb. So the voltage doesn't change in a parallel circuit. The current does change in a parallel circuit. The current is actually shared between each branch. So it has the same amount of voltage going through each branch, but that current is now cut in half because half of it's going through light bulb 1, half of it's going through light bulb 2. Does that help, Diego? So that's what your diagram should have looked like, where your voltage was the same, 6 volts for each light bulb, and your current was 4 volts total, but 4 amps total, 2 amps going through each branch. So that's what it should have looked like. So here are the answers, of course, to each part. I'm not trying to keep the answers from you guys, so make sure you understand how the voltage changes and the current changes for both series and parallel circuits. You should have to, you should be practicing that in the circuit building assignment that I posted. And of course, you'll be quizzed over this, not next week, but the week after next, after spring break. So here is a little quiz. Here's a little quiz to take. You're welcome. So I'm going to stop sharing. And I'm just going to send my face forward now. There we go. So that you guys can take your quizzes in peace and not be judged by your peers. Although I will judge you once you take the quiz. So that's asking for the total current. So number 1 is asking for the total current through the circuit. Maybe that helps with number 1. Looks like all the other admin dropped out. What's up? Man, I guess they're just too good. Too good for Mr. Smith's live session.
I think it's a busy day. Edwin said, Mr. Smith, you are evil.
Yeah, I saw that. That's fine.
Okay, all right.
So question number 2 would be asking about the current going across the first component. So basically right on the other side of resistor 1. That's what number 2 is asking. Number 3, of course, is asking for the resistance across resistor 1. What is the total resistance of resistor 1? Number 4 is asking for the voltage going across resistor 2. So that 10 ohm resistor, how much voltage is going across it? Number 3, of course, is asking for the voltage going across that third resistor. Let me tell you, this is a tough quiz. You're welcome for this one. Then, of course, number 4 is asking for the total voltage coming from that battery. So let me give you a hint, you guys, while you're taking the quiz. If you know the total current in a series circuit, then you know the current throughout all the circuit. Series has the same current throughout the entire circuit. So that means you know the resistance and you know the current for each resistor. Or you know the current and the voltage for resistor 1. This requires you to use Ohm's law to go back and solve for the voltage for resistor 2 and the voltage for resistor 3, and then solve for the resistance for resistor 1 using the current and the voltage. So let's see here.
Mr. Smith, many people want to know if the quiz on Nearpod is going in as a quiz grade.
No. Don't worry, if you get these wrong, don't sweat it too much. This is a participation grade, okay? Just the fact that you're here, you're trying, that's what I'm looking for, okay?
Good to know, because Ryan says, I don't understand anything.
Okay, that's all right. So this is the last part of the Nearpod. So basically what I'm going to do for the rest of the time until 2 o'clock is just hang out and answer any questions that you have over the Nearpod. Speak English, what? I'll answer any questions over the Nearpod or previous quizzes as well. So Ryan, if you're struggling, just hang out and I'll answer your questions. Why would a light bulb get brighter in a series circuit if all? So Gracie, the question is asking you, how could you increase the brightness of that light bulb? What could you change about the circuit in order to increase the brightness of the light bulb? That is what the question's asking. So you can change the brightness of the light bulb by basically changing how much energy is going across it. What are different ways you could change that? That is the question. Brightness is directly dependent on the amount of voltage going across it. The higher the voltage, the higher or the brighter the bulb. Hopefully that answers your question. All right, let's go over the quiz, and I'll show you all the answers. Okay. Let me see here. Where is that image? Huh. Tell you what, I'm gonna all right, so this is what I'm going to do. I'm going to unshare this. I'm going to take us back to the quiz real quick. I'm going to cast my screen. Okay. All right, so if you look at the live, you should be able to see the quiz now posted on there, right? So let's pull up the image. So number one was asking, looking at this diagram, what would the total current be? Well, looking down here, in a series circuit, the current is the same no matter where you are in the circuit. So because we're here at, because we have a current of 3 amps in between these two resistors, which could be light bulbs, our total resistance is 3 amps, no matter where we go in this circuit. So our current in the circuit is 3 amps. So that should have been 3 amps. Next question, please. All right, so looking at the diagram, determine the current of I1. So no matter where you are in the circuit, it's still 3 amps. The current is still the same. That's not going to change for a series circuit. So 3 amps once again. Now, I don't really like this question because it doesn't specifically say where I1 is, but it doesn't matter because we know that the current is the same no matter where you are in a series circuit. So that is still 3 amps. Now, if we're looking at resistor 1 we know has a current of 3 amps and a voltage of 12 volts. So if you work that math out, we know resistance equals voltage divided by current. All you have to do is 12 volts divided by 3 amps. Looks like that. Got it. 12 divided by 3, of course, is 4 ohms. So that resistor 1, should be 4 ohms. Now, if we know the resistance instead, how do we find the voltage going across resistor 2? Well, that's not too hard either. All you have to do is rearrange our formula to solve for voltage rather than resistance. So we say, well, voltage equals resistance times current. So R times I will give you voltage. So our resistance is 10 ohms for resistor 2, multiplied by our 3 amps of current. That'll give us 30 volts of electricity going across resistor 2. So that guy should have been 30 volts. So number 3, or resistor 3, we do the exact same thing as we did for resistor 2. We have the current and we have the resistance. We say voltage equals resistance times current, resistance of 6 ohms, current of 3 amps, 6 times 3, 18 volts. See if I can show that. Right there. Okay. So when you go back to review this, there's the answer. Hopefully you can see it. So resistance times current will give you the voltage, 18. Bam. Now the last question is, what is the total voltage? Well, the total voltage is each voltage added up total. So VT, or V total voltage, equals voltage 1 plus voltage 2 plus voltage 3. So the voltage going across resistor 1, the voltage going across resistor 2, the voltage going across resistor 3, all added together, we got 12 volts plus 30 volts plus 18 volts. That gave you a total of 60. Let me see if I can show that too. A little math for you there. Yeah. There you go. So that last guy should have been 60 volts. So hopefully you guys did pretty well. Hopefully you understand at least now what this was asking for. And that's all I have for you in terms of the Nearpod. So after going through all that and working on the assignment in teams, hopefully you feel confident in yourself in order to be prepared for next week or the week after next. Let's take it back to this. There we go. Stop exposing me. Just. Okay. Pictures won't load on the quiz. Just try refreshing. They should load. I double checked the form, made a list, checked it twice. The images should load. I worked hard to make them load, okay? Or to make sure they were in there. So try closing it and refreshing it to double check that it functions. There should not be 2 quizzes in here. Please, God, tell me there aren't. Ugh. Why are there 2 quizzes? Crap. Okay, Megan, close it again. Make sure you click on the right one. It should be the last quiz on there. I just deleted one of them. Amani, how will we know to multiply to find our answer? Well, it depends on what you're solving for, because you're using Ohm's law, I'm assuming, to solve for resistance, or you're solving for voltage, or you're solving for current. So think about what you're trying to solve for and what formula do you have to use in order to find it. Brian, I don't know why you're asking that. This isn't the classroom. Okay, potential difference is the difference in energy between the positive side and the negative side of the battery. So the battery has a positive and a negative charge, right? And that difference in charge is the potential difference. So the higher the difference in charge, the higher the voltage. That's what potential difference means. It's basically the energy a battery has. Natalie, if you're ready to work on the assignments, work on the assignments. You don't have to hang out here. You're good to go. Belle, if you don't have any lingering questions, you can go work on assignments. How do you calculate equivalent resistance? Did I put an equivalent resistance question on there? Crap. See, Natalie. Anonymous, have fun with your lunch. I don't know who you are still. Yeah, so if you're working on the Brain Genie, now is a good time because we should have hit everything in the Brain Genie now. All of it should be part of this these calculations now. So hopefully you can complete more of the Brain Genie than you were before. Anonymous, I still don't know who you are, man, or person, cheeseburger person. Okay, so Megan, are you talking about number 5 on the quiz? Let me just pull it up real quick. The image takes some time to load. Grace, you asking the same question. Hang on. Number 5, ask for equivalent resistance. So I'm pulling it up right now. Maybe. Does anybody have to cancel their vacation plans or traveling plans? I had to cancel my flight back home. That kind of sucked.
Oh, I'm sorry, Mr. Smith.
That's all right, you know. Georgia's my new home, so why?
Oh, gosh.
Right?
Good luck with that.
What are you saying?
I don't know. I'm not sure. Mr. Smith, would it be okay if I left you to fly solo so I can have a short break before my 2 o'clock class?
No.
Okay. I'm going to do it anyway. Okay, cool. Great. Thanks, Mr. Smith. Have a good spring break. See ya.
Okay, so you guys, the equivalent resistance question, number 5, it's just asking for the total resistance, okay? So number 5 is just asking for what is the total resistance in the circuit. So don't overcomplicate it. I already showed you in the Nearpod earlier how to find resistance. So actually, speaking of which, let me go ahead and upload the PowerPoint into Teams now. Edwin, no, I didn't get Doom. I was never a big Doom fan. Okay, Sierra, potential difference is just basically the energy in the circuit. What is the energy flowing through the circuit from the positive to the negative side or the negative to the positive side? Like, what is that energy difference? That is by definition the voltage. So what is the voltage in the circuit? The higher the potential energy difference in a battery, the higher the voltage is. Anonymous, no, you shouldn't be scared. If you're sick, just stay home, relax, get rest. Okay, so as we speak, I'm uploading the PowerPoint now. Well, because it's more complicated than that, Sierra. Voltage is the difference in potential energy within a circuit. So they're hand in hand, it's just not exactly the same. So yeah, basically, if you change the potential difference, you're changing the voltage. Okay, that's basically all it's saying. Can you use a lemon in a circuit? Depends on the circuit. A lemon holds a certain amount of voltage, so you can plug a light bulb, or you can power a light bulb using a lemon, depending on the light bulb, like a little LED. You know what? Maybe I'll do that. Hang on. Find the potential energy, you have to find the voltage. Yeah, I won't be asking you to calculate potential energy in joules. You'll just use voltage as the energy within the system. Alas, I cannot do the lemon experiment. Sorry. Don't have galvanized nails. What are you gonna do? Actually, hang on. Can I just use any nails? See you, Edwin. Have a great day, man. All right, hang on, I'll be right back. Oh, all right. Sierra is still very confused. Sierra, basically potential difference is just changing the voltage, okay? That's it. Don't overcomplicate it. See you later, Jenny. Have a great day. Are you talking about the quiz? Are you talking about questions on the quiz? Is that what you're asking for, Sierra? Any copper wire in here. How does a bulb get brighter? Well, you have to change something about the circuit, Taylor. It's asking you, what would you change in the circuit in order to increase the brightness of a light bulb? A light bulb brightness is directly dependent on the voltage going through it. Okay? No and yes. Just think about, how would you change the voltage in going through a light bulb? Look at the different choices that it provides you and how you would change that. All right, got ourselves a lemon here. Let's get a couple light bulbs out, probably just one. Stick our nail in. Let's get one of these guys. Let's get one of these guys. There. So increase the voltage, something like that, yeah. Should I do the practice before the quiz? Yeah, definitely. You want to do as well as you can on that quiz, right? Ah, crap, I need an alligator clip. I don't have no freaking alligator clip. Maybe this will work. Maybe. Well, that's one way to do it, Taylor. No, I can't get the light bulb to light up. It's not working. I don't have any copper wire. I think that's the main issue. No. Someone said we're going to have to redo the semester. That is just a rumor. No one said you're actually going to have to redo the semester. All right, well, aside from my failed lemon experiment, any other questions? Questions, comments? Still got about 20 minutes left on here. I'm still gonna eat this lemon. Can't let a good lemon go to waste, right? If you add a bulb to a circuit, does that take away from the voltage from the other bulbs? Yeah, absolutely. If they're in series. If you hook another light bulb up in series, the light bulbs will actually get dimmer because you're sharing the voltage from the battery through each different light bulb. So the more light bulbs you have in a circuit, the dimmer they'll get. In fact, let me see if I can show you. How long do I think the virus would last? Well, It'll last as long as people don't stop going out. Probably for a couple of months, at least. Unless that guy issues martial law. That'll be interesting. Probably won't happen. Probably won't. Are we doing lab or intro? Oh, for the circuit. You can just do the lab. That's fine. You should have access to everything in the lab section. Daniel, yes, we'll have a test. We will definitely have some tests. We just have to figure out how to do it yet. How do you screenshot? Control print screen if you're on a PC. If you're on a Mac, I don't know, look it up. Here, I'll look it up for you. Screenshot on Mac. Yes, basically, Taylor, if you're changing the potential difference, you're changing the voltage. Okay, Sierra, if you're trying to take a picture on a Mac, press Shift Command 4. That should do it. And then drag whatever you're trying to. Oh, well then just Control print screen, the little PRT SCR button on your computer. Oh, oops. Any other questions, comments, concerns? My 10 people left hanging out with Mr. Smith for some reason. Don't have anything better to do? Because I get that. My circuit's not working. Make everything so complicated. I mean, just get good, Sierra, and you'll understand everything. It's that life is more complicated than it seems, okay? Voltage is very similar to potential difference. There is technically a difference, but you can kind of think of them as the same thing right now. I don't think this breadboard works. I think that's my main issue right now. What's the difference? It's that voltage is technically the drop in voltage. So the energy drops as it goes across different things, right? And so voltage is that amount that it drops. Potential energy is basically the energy within each part of the battery. I don't know if that helped. The Ohm's Law quiz, study last week's PowerPoint. So week 2 of Teleschool. Here's the cat. Cat's on the bed. You can literally see that little black, this little thing right here. That's the cat. Maybe one of these wires doesn't work. Okay, good. Super do. Come here. Come here, Super do. No. Here's the cat. There you go. See her little paws. She's all cat-like. Whew. All right, kiddos. Any last minute questions? I'll give you a couple more minutes to ask questions, and then I'm out. What's goody? We saying that still? I thought that had died off. And why aren't you guys social distancing, Sierra? See you, Taylor. Have a great day. See you next week. See ya, Anonymous. Still don't know who you were. Well, good. See you, Daniel. Have fun with stuff. All right, kids, last minute. Then I'm heading out. See you, Adrian. Yeah, happy quarantining. Happy social distancing. All right, kids. We'll see you guys next week. Send me an email if you have any questions.